Welcome to a lesson on how to determine the number of subsets of a given set, as well as how to determine the number of subsets of a set with a certain cardinality or a certain number of elements. Let's begin by considering set A with elements 1, 2, 3, 4, and 5. The question is, how many subsets of A are there? For review, the power set of A is equal to the set containing all of the subsets of set A, and therefore the cardinality of the power set of A is equal to the number of subsets of set A. So for example, if set A is the set with elements 1 and 2, the cardinality of the power set of A is equal to 4 because the set has a total of 4 subsets, which we should recall the 4 subsets are the empty set, the set with the element of 1, the set with the element of 2, and set A itself. If set A has elements 1, 2, and 3, then the cardinality of the power set of A is equal to 8 because set A has a total of 8 subsets. But again, our question is, how many subsets are there when set A is the set with elements 1, 2, 3, 4, and 5, or what is the cardinality of the power set of A? Think about how we would build a subset. For each of the elements in A, decide whether or not to include the element in the subset. We need to decide yes or no for the first element, yes or no for the second element, yes or no for the third element, and so on. For each of the 5 elements, we have 2 choices. And therefore, the number of subsets is 2 times 2 times 2 times 2 times 2, or 2 to the 5th, which is equal to 32. And this is due to the multiplicative principle or counting principle. So we can generalize and say the cardinality of the power set of A is equal to 2 to the power of n, where n is the number of elements in set A. And now of the 32 subsets of set A, how many have 3 elements? We might be thinking that the multiplicative principle indicates that there are a total of 5 times 4 times 3 or 60 ways to select 3 element subsets, but this isn't quite right because notice 60 is greater than 32, and we know we have a total of 32 subsets. This isn't correct because 5 times 4 times 3 equals 60 indicates that the order of the elements matter, but we know the order of the elements does not change the set. For example, notice these 2 sets with the elements of 2, 4, and 5 are the same set, but in the calculation of 5 times 4 times 3, which gives us 60, these would be counted as different. However, we can correct this by dividing. For each set of 3 elements, there are 3 times 2 times 1 or 6 ways to arrange the 3 elements, which are counted as different in the 60 ways. And therefore, we can determine the number of unique subsets by taking 60 and dividing by 6, which gives us 10 subsets with exactly 3 elements. Before we look at an easier way to determine the number of subsets with a certain number of elements or a certain cardinality, let's look at a table. Let's complete the table below, where in the first row we have the number of elements in the subset, and then the second row we have the number of subsets. For example, how many subsets of set A have 0 elements? That would just be one set, the empty set. And we can also easily determine the number of subsets with 5 elements, which should be set A itself, and therefore there's only one subset with 5 elements. And now let's go back to the number of subsets with 1 element. Well, because there are 5 elements, there would be 5 subsets with 1 element. And now if we think about this for a moment, the number of subsets with 4 elements is going to be the same as the number of subsets with 1 element. Every time we form a subset with one of the 5 elements, we leave behind 4 elements that would form a subset with 4 elements. And therefore, there's also 5 subsets with 4 elements. This also indicates that the number of subsets with 2 elements and the number of subsets with 3 elements is going to be the same. And again, that should make sense. If we take 2 of the 5 elements to form a subset with 2 elements, the 3 elements left behind would form a subset with 3 elements. So notice so far we've counted 6 plus 6 or 12 subsets. And because we know we have a total of 32 subsets, 32 minus 12 is 20. 20 divided by 2 is 10, which leaves us 10 subsets with 2 elements and 10 subsets with 3 elements. But there is a much easier way to determine the number of subsets with a certain number of elements, a certain cardinality, using combinations. A combination of objects is used when order doesn't matter. The number of subsets of a set of size n, each with cardinality k, is equal to n choose k indicated by any of these three notations here. So again, n is the number of elements in the original set, and k is the cardinality or size of the subset. And we define n choose k, or n items chosen k at a time, as n factorial divided by the product of n minus k factorial and k factorial. Let's verify the formula by verifying that for set A, there are 10 subsets with 2 elements. Because set A has 5 elements, and we're trying to determine the number of subsets with 2 elements, we need to calculate 5 choose 2. Which means n is equal to 5 and k is equal to 2. Applying the formula, we have n factorial, which is 5 factorial, divided by the product of n minus k factorial and k factorial, which is 5 minus 2 factorial and 2 factorial. Simplifying, we have 5 factorial divided by the product of 3 factorial and 2 factorial. And now we'll go ahead and expand the factorials. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And 2 factorial is 2 times 1. And now we'll go ahead and simplify. 3 divided by 3 simplifies to 1. Notice in the denominator we have 2 times 2, which is 4. 2 times 2 simplifies to 1 in the denominator, and the 4 in the numerator simplifies to 1. Notice how this does leave us with 5 times 2, or 10, which is what we expected from the table. Set A has 10 subsets with cardinality 2, or 10 subsets with 2 elements. And before we go, I do want to mention most calculators do have a combination function. For example, here is the Desmos Scientific Calculator. If we click Functions, and then NCR is the combination function, and then we go back to the main keyboard and simply enter 5, 2 for 5 choose 2, and the combination is calculated, which does verify the result is 10. I hope you found this helpful.